Hello and welcome to a new video series here on the Lötwig Fusel channel. This video series is called Real-Time Rendering, and before you ask, yes, there was already a series called like that, but it's abandoned. So here we are again, Real-Time Rendering, a computer graphics course in the topic of game engines by Lötwig Fusel. So real-time rendering, we are finally there, probably something that you guys were waiting and thrilled for ages. Now, what do we want to do? Well, we want to do real-time rendering. What does that mean? Well, we want to render games. We want to render images like that. This is a computer-generated image from a game, from the game Mirror's Edge by DICE Electronic Arts, and it's a nice game. Play it. If you don't, I'm gonna be sad because you don't play it. But yeah, this is just an sample image, what we want to do. We want to archive rendering amazing images. Now, how do we archive this? Well, with a hell of a lot of math, a hell of a lot of faking real effects, a hell of a lot of computation powers, a hell of a lot of ray tracing on GPUs that call themselves NVIDIA RTX or AMD, whatever. I don't know how AMD calls them. And yeah, what we got is an amazing image. Now, big of a journey to get there, and we're not going to go that far. I don't think that we're going to get so far rendering so nice images. Is already falling apart because I can't do 3D modeling. If I could do 3D modeling, we might have nice 3D models, but no, I don't. I need to buy them, the 3D models, or I need to download free models, or I need to learn how to do them, but currently I don't. Alright, so where are we? So we are on YouTube. What? No. Where are we in the big picture of the game engine? Well, the game engine is always a big topic, and you might already have seen architectural diagrams of a game engine. And if you're taking a look at the game engine, you're gonna find in, some more or less reason an architecture like that. Now, all other subsystems of the game engine that handle rendering, like the scene manager or whoever wants to render or to interact with the renderer, is here currently called the GE, the game engine. The game engine is the big black box that is doing all the work like scripting, level loading, multiplayer, audio. All that stuff is now currently hidden inside this box, game engine. Now, what the game engine does, it interacts with a so-called renderer, the RR, the renderer. I just called this RR. I don't know if this is a real term, but for me it's going to be the RR term. And the renderer's task is to take the information from the game engine. For example, if the game engine tells the renderer, hey, create a new mesh at that location, the renderer needs to perform the task. The renderer needs to create the infrastructure for these, prepare this for rendering, load shaders, load the 3D models, and be ready to render. Well, that's the name. It's a renderer. It renders. And how does the renderer render? Well, the renderer renders by calling a rendering API. Now, if you are on a game engine, the rendering API could be anything, right? The rendering API could be DirectX 12, DirectX 11, Vulkan, OpenGL, Metal, or like the proprietary Sony stuff for the PlayStation, whatever. We don't know what it is. So normally what you do is you're not going to directly call the graphics API from your renderer because you don't know which graphic API is going to be used. So what you normally also have is a rendering interface. The rendering interface are a set of RPs and toolkit functions, toolkit classes that help you calling the actual renderer. Now, in general, what you do is you basically say, hey, rendering interface, give me or create me a context for DirectX 12, and it's going to return you like an my global instance of a rendering pointer, and this global pointer, or not global pointer, but this large huge pointer can then be used to interact from the renderer. And what this is then doing, it is going to do the real API calls, which are in general just calling the D3D12 implementation, for example, or the Vulkan implementation, for example. So this is the general architectural diagram that we have in terms of game engine. Now, where are we? We are here. We are going to discuss the renderer, not the game engine, not the rendering interface, not DirectX 12, neither Vulkan. We're going to drop Vulkan completely, actually. And what we are doing is just talk about the renderer. We're just going to talk about the math, everything that is involved to render it, how to write shaders, how to write proper shaders, how to manage your objects, how to manage what is drawn, when to transfer them to the GPU, and all of that nice stuff, but not the rendering interface, not how it looks on the DirectX 12 side, Okay, yeah, we do know how it looks on DirectX 12 side because we need to describe pipelines, we need to describe input layouts, we need to write shaders. So it is kind of like DirectX 12 what we're gonna do. Or you of course need to know DirectX 12 how we do it, but we're not going to talk about implementations, how this glory of shader hot reloading works. No, we don't care about that one. On the other side, we also don't care about the game engine, right? We don't care about how to draw debug UI. We might do it still with IMGUI, but we don't care about how the game engine implements input, how the game engine implements windows, how the game engine implements maybe sound, if we have sound. I don't think so. How the game engine handles everything. Like, we don't care about this. We just care about how the renderer implements. We're just going to expose some features, for example, a camera, but how this camera is transformed and moved around the scene, we don't care. It's part of the game engine. It's going to be implemented by somebody else, me in this case. Now, what are we doing? Like, this diagram above here is where we are in terms of game engine, but this is way too complicated to do on our own. We care about what we are doing. Well, we do have a bit more simplified diagram of that concept. As you can see, I've shaved this down to 3 important boxes that we need. We need the DR. The DR is the direct renderer, so I like to call it direct renderer because it's using DirectX, direct R renderer. It is the direct rendering interface to kind of like call DirectX 12 calls. Then in the middle we have our renderer. The renderer should be as unshaved down as possible. So in theory, if you understand how this renderer works, it should be no problem integrating it above here and then calling a different rendering interface. So this should be at not shaved down at all or minimal shaved down. The renderer itself, of course, needs to be called and needs to be integrated into a framework, which is going to be done by the IE. And this is not standing for Internet Explorer, even though people tend to think IE is Internet Explorer. No, in this case, it's the interface engine. It's definitely not called a game engine because we're not going to write a game engine. This is going to be an interface engine, which only purpose is to call the renderer and to provide like user interface, debug, or not user interface because we're not going to have a user, we're just going to have like debugging or development interface. But the interface engine, it's just the basic framework that handles calling the renderer, interacting with windows, calling the renderer, setting cameras, moving the camera, input handling, all of that stuff, it's going to be implemented there. And what are we doing from that? Well, we are doing the renderer. The DR is going to be written by me. The IE is going to be written by me. The RR is partially going to be written by me. Of course, everything is written by me, but I mean off video. You're not going to see how I implement DR. If you're interested in DR, watch my DirectX 12 videos and take a look at the source code. If you want to see how the interface engine works, take a look at the source code. On the videos, we're just going to discuss the implementations of the renderer and just the relevant implementations of the renderer. So all the framework, how to create projects, how to file loadout, this is all going to be done. I might also have the classes already created, and then we're going to add the methods and shape and model how the renderer works. That's the whole idea there. Now, what will you learn in this video series? You will learn how rendering math works. You will also learn how the GPU works. I already done that in the D3, D12 videos, but I think it's the right choice to do it in this video series again. Even through this is gonna be, I might need to rewatch my old videos to talk to you how the rendering works, how the GPU works, and yeah, how this in general works. Like this, how GPU works and how 3D rendering works. This is like one big topic. It's basically explaining the rendering pipeline, and that's it. Now, after we have decided or discussed how the GPU works and how even modern concepts of the GPU work, we're gonna talk about how we can render a simple 3D scene. Now, a simple 3D scene is going to contain, first of all, out of 3D objects that are just going to be drawn. Then we're going to add all the gloriness that we need to make it convincible, step by step, until we end up by something called Blin-Phong shading, and or Blin-Phong lighting model if you are completely correct, but yeah, or reflection model, I don't know, something like that. And as soon as we are at that model, you basically know how you work with the shaders, how the rendering engine works. We can start tinkering around building scenes. using the concept of cameras, using the concept of light, and then later on move to more advanced concepts like deferred rendering. Later go in and then start how we can render physical correct images. So Blin Fong, what we're going to do on simple rendering, it is just going to be an estimation of how things should look. There are multiple things you need to take into account when you want to render physical correct, and physical correctness is a very important thing. And after we are done with that, after we can render physical correct, we're going to explore multiple tricks on how to create good looking scenes. This is where the fun begins, because this is interesting. What we're going to do there is stuff like shadows, global illumination, bloom, ambient occlusion, all the tricks that developers tend to use to let you think that this is a real scene. And not just a computer generated, badly looking piece of art. Maybe you want to have a piece of art, which doesn't look right, but I'm more like the realistic games guy, so yeah. Now to a even more important slide. What will you not learn? Well, you're not going to learn how to write a game engine. That's definitely not the scope of the series. You also will not learn how to write a game, right? The whole rendering system that we're going to write, it's going to be a nice framework to tinker around and play with shaders and play with rendering techniques. This is how you call these little magic rendering techniques. It's just going to be that. It's just going to be a framework for exploring graphics. Not a game engine. It's not going to be useful to create games. You might be able to create three-dimensional scenes and view them and enjoy looking at these scenes. But you will not be able to use it as a game engine. And since it's not a game engine, you cannot write a game, right? You're not going to have any scripting features in there. At least I don't plan on putting scripting in here. Maybe we do later on put something like animations in there, or might even... No, I don't think that we're going to do scripting. If we're going to do something, we might do animations, because moving objects are a thing in game engines and in renderers, and are a thing to consider. If everything is static, you can bake lighting, and you're going to have an amazing scene with completely baked lights, but the joy of a game engine is that you can move and that objects can move, and that's important as well. So we might have animation later on in here, but we definitely not be able to build a game, right? We're not going to have any shipping methods. It's not that you can press exploit and you get an exe and the package file and it's a game that you can distribute. It's not going to happen. You're also not going to learn how to do proper API abstractions and cross-platform development. This is all going to be hard glued to Windows. I'm not going to bother putting any interface in between. It's going to be hard Windows, nothing else. No interface in between, even though I already hate saying that, because that's not how I like to do stuff, but that's it. We're not going to have API abstractions. This is going to add a ton of overhead to applications, especially in terms of source code and manageability of the source code, but also in terms of performance. But performance we don't care in this case. We don't want to do this. We want to have a simple system that you can understand. Another thing that you're not going to learn, obviously, is you're not going to learn how to write C++, Python, or HLSL. Even these are three languages that are going to probably be used in the project. We're going to have C++ as a main source code. We're going to have Python for managing the repository, having scripts for generating the project and stuff like that, maybe even pre-process steps that transform assets or something like that, but you're not going to learn how to write Python. I'm just going to write down, assuming that you understand what I'm doing. Same on C++, same on HLSL. We're going to write shaders in HLSL, and I'm going to explore HLSL. Actually, HLSL is a bit different. You're going to learn a bit of HLSL here as well, but you should at least know how the basic syntax is. Yeah, right, HLSL is basically C, right? But yeah, that's a different story. Now, what I'm also not going to tell you is how you're going to manage your repository, your builds, and your distributions, right? This is not the scope here. You're going to have a intact Git repository that you can clone and use. I'm going to show you one step how you can create your Visual Studio solution and open it up. This is definitely going to be in there, but it's not going to be telling you how to build properly, how to distribute this if you want to show it to somebody else. That's going to be the scope. Also not going to be the scope here, how to write the DR and the IE, so the direct renderer and the interface engine. See the DirectX 12 video, see the GitHub source code, you're going to see how this works. I'm going to explain how the functions work, but I'm not going to show you the implementations and not going to go into that, at least if we don't have a bug that I need to fix on time. So that's definitely it. Now, what are your requirements? Well, you should know the basic math. Basic math is important. I would love to say what you need, but high school math. Like, you should know how a equation works, how to solve a function with one or multiple unknown symbols. You should know how like pi works with circles and stuff like that. But yeah, just basic high school math, but not like advanced stuff like vectors. We're gonna take a look on what vectors are. We're gonna revisit them. We're also gonna revisit matrix math. We're gonna revisit, if we need this, a three-dimensional math, so bounding box intersection and things like that. But this is all something that I hope I can do on demand, so I'm not gonna have like too many math videos at the beginning. I try to bring them as you need them. Then of course you need to know C++. If you don't know C++, you're definitely wrong here. I have a C++ beginners tutorial on my channel that you can watch. Definitely a requirement. You do need to know C++, or you're gonna get lost. Next thing is you need to have knowledge of DirectX 12 and HLSA syntax. DirectX 12 not 100% required, but at least like the rendering pipeline. We're going to revisit some of that in this video, but it definitely helps if you know DirectX 12. If you have any issues later on working with the code base, you're going to need this. You need to have, you need to know what's going on and how to solve problems. Yeah, same with the HLSL syntax. HLSL syntax is important. It's basically C, so it shouldn't be a problem, I think. Now, a bit of an overview on how the series is going to be laid out. We're going to start with math. And I have forgotten something there. We're going to start with math and the basics on how the GPU works. So, was there not the way to do like... to use like a pencil to write on there, but it seems like not. Why can I? Interesting. There we go. Math and GPU. It's gonna be the first thing that we take a look at. And later on, simple rendering, PBR and deferred rendering, effects and global illuminations. So yeah, have fun learning, and just as a little side note, videos will come when they are ready. This is not a regular video series. So very important information here. I'm not going to put any stress with this video series on that, because this video series requires some major work from me. Like the DirectX 12 videos were already quite tough. DirectX 12 videos were like, yeah, for a 1 hour video, I had like 5 hours work. Or maybe not that high, but at least like 3 hours to 5 hours work for one video. Like these were bilingual series, so the work was obviously a bit longer, which I'm not going to have here. But in general, I have many things to do in this video series. I need to write a code base, I need to do research, I need to do a slide, and I need to record this, I need to edit this, and I'm gonna try to make these videos perfect. These are not me tinkering around videos, these are me knowing what I'm doing. Maybe even just explaining source code or having source code aside, copy and pasting it in or typing it down from what I've already did. But that's important here. This is a very advanced video series that is requiring a lot of attention from me as well as you. I'm currently in the state that I might be able to do this. I'm currently laying all the stones on my personal and professional career to have at least 1 or 2 days a week for YouTube. We're gonna see how this ends, how it just goes. I don't know, but just that you know. I'm working hard on this from now. This is a commitment that this video series is starting now, and especially this professional. But videos will come as they are ready. I'm working on them on a regular basis, but the videos might not come regularly. Just a little disclaimer here. If you're watching this, probably there are already a few videos available, because, yeah, at least if you're not a subscriber, you're not going to see the video directly when it comes out. But many of you have, obviously, and you want to do this as well. So become a subscriber now. becoming a subscriber. Every subscriber counts, and every subscriber that's going to be on this channel, and every like the video gets, and every view the video gets, is going to allow me to dedicate more time into this video series. I might also have a few more options to support me in the future, but currently this is the only way: supporting me, subscribing, liking, commenting, watching. But yeah, I don't want to be too, oh no, go in here, subscribe, subscribe, subscribe. At least I'm just doing it at the end of the video, right? So yeah, thank you for watching. See you in the next video. Make sure to like and subscribe, and until next time, bye.